here's a little point about trig limits that's important to remember. When we take the limit as theta goes to 0 of, say, sine of 2 theta over sine of 3 theta, a lot of people have the instinct to just say, okay, well, that's immediately equal to 2/3, and we don't have to go through all of the little details. But let's change this a bit. Let's change it to 2 theta squared inside the sine. Now, if we want to figure out this limit, we should be precise. We should take every last moment and really make sure that this is done correctly. For us to be able to deal with these limits, we saw that something that worked very well was to break them up into separate fractions. And what you needed is, of course, sine of box over box. And to take that limit as box goes to 0, that's equal to 1. So I would like a 3 theta over here, which means that I then have to divide by 3 theta. I would like 2 theta squared over here, which means multiplying by 2 theta squared. And notice right here that extra 2 is definitely going to cause some issues. Now, if we're going to be absolutely precise, we should write down that this is the limit as 2 theta squared goes to 0, and that this is the limit as 3 theta goes to 0. And then what remains is simply as theta itself goes to 0, 2 theta squared over 3 theta, a little bit of cancellation, and we might want to say, we don't really have to, but if we were going to be completely precise about absolutely everything, then we can say over here, since as theta goes to 0, we have 3 theta and 2 theta squared also going to 0. At this point, this is completely faultless, and this first limit is equal to 1, second limit is equal to 1. The ones that take a long time to write give us the simple bits, and over here we end up with 0. So if we have a 2 theta squared, well, this sign is going to 0 much faster than this sign is, and it ends up dominating the fraction, and we have a limit that is equal to 0.